Hi, I'm going to do an example of decay rate. I'm going to do a half-life example. This is one from the homework. It's the number 9 in the homework. So just kind of going back, whenever you think about exponential growth or decay models, this is what they look like. A0 is the initial amount, T is time, and then K is either positive as the growth or negative as the decay. Okay, so let's take a look at this one here. I'm going to go ahead and write down the model here just so we have it. Okay. For the following table to the right, it says they want you to find the decay rate for a half-life of 11.4 days. So that way, what that means is after 11.4 days, you have half of the original amount. Okay. So if this is your original amount, in 11.4 days, that's your time. You have half of this original amount. So I'm going to have 0.5 times A0. Okay, from here to here, I divide both sides by A0. And that's how I get this equation right here. What I want to do is I want to find K, which is the decay rate, which we know should be negative. At this point, we have an exponential equation with different bases, so I'm going to take the log of each side. Since it's involving e, we're going to take the natural log of each side. If I take the natural log of this side, I'm just going to kind of write it in here. It's 11.4K. Make that a little bit neater. Natural log and e are inverses of each other, so this just becomes 11.4. And then I take the natural log of this side. So next step I want to do is I want to get this K isolated. So I divide both sides by this 11.4. So I get natural log of 0.5 divided by 11.4, which we plug in our calculator. I have it in the calculator to the right there. We get a negative number. The homework asks us to round the 6 decimal places, so I marked it 1, 2, 3, 4, 5, 6. We want to run right there. So this is my value of K, my decay rate, which again should be negative if it's decaying, which means the population's reducing. It should be positive if it's growing. Okay, so that concludes the homework examples from section 3.5.